us with a few notes, and make sure you remember that for this, at this point, we do not need log button on the calculator. So the logarithm gives you the exponent, so we just guess nice exponents at this point. In other words, I'm going to, for instance, with log base 5 of 625, it means what power of 5 gives you 625. We'll type in 5 cubed on the calculator. It's only 125. That's not enough. 5 to the 4th is 625. Oh, bingo. That's it. Then the answer, if you had typed in 5 to the 5th, 3125, that's too much. Try something smaller. Log base 5 of 625, the answer is the exponent. So for the first problem, 4. 3 to what gives you 243? Mess around with the calculator, you see that it's 5. In order to do this next one, we have to think of 0.2 as a power of 5. 0.2 is 1/5, so that's 5 to the -1. So the exponent, which is what we want, is -1. 9 squared is 81. Log of a million is 6. We'll write a little note. Okay. Log base x of x to the 7 is 7. For those of you paying complete attention, this is as long as the log is defined. We don't try and make sense of powers of negative numbers as a continuous thing, because, for instance, -1 to the 1/2, that's the square root of -1, isn't real. Log base 1 of anything doesn't make sense because 1 to all powers is always 1, so you can't get other numbers besides 1. Alright, going on, we have log base 3 of x. What tells you the base? Okay, so just as an answer, the point is 3, 1, and some notes about that. Okay, a slightly more reliable way is to look for the vertical asymptote, and then we always go through 1, 0 for any base. So you look for 1 to the right of the asymptote, and then the distance between the asymptote and where you are 1 up from that is the what the base is going to end up being. Okay, so on the next couple of problems, we're just practicing more of that. So if I, again, look at for 1, 0, yes, so that means, and a vertical asymptote at 0, that means we haven't been moved up, down, or right or left, so we look for the height of 1. Okay. Why do different bases have 1, 0? Because log of any base of 1 is 0, because a to the 0 is 1, as long as a is allowed, of course, as a base for the logarithm. All right, so now again, we look first for the vertical asymptote. Then we go 1 unit to the right of the asymptote and look for the point that's the equivalent of 1, 0. Looks like it's been moved down 2. So, and then we look for the point that is 1 unit up from that, and it is 3 units over from the vertical asymptote, so we are ready to go. It's log base 3 of x. Again, let me write that little note that it's and then minus 2 because it's down 2. This one we've moved the vertical asymptote over. And don't forget, when we're moving left and right, we're replacing x by x plus or x minus. So and it's always opposite for x's. So we're going left 2, and I look for 1 unit over from the vertical asymptote. Oh, it is not moved up or down, but it has been moved, notice, left 2. And then I look for 1 unit up from that, and that distance is a grand total of 5, so the base is 5. And notice it's 5 moved left 2, so yeah. Next page. I know, they don't correspond on the printed version. Okay, so let's see. They've moved things over. The VA is at -5. So it's left 5. So it's log base something of x plus 5. And we are also down 2. And what's the base? If you go up from this point 1, box right there. Okay, and that distance is 3. Okay, what is this? This is right 4. And up 3, yeah, up 3. Okay, and then up. That distance is 2, so it is base 2. There we go. Okay, I'm going to say for this, leave numbers in exponent form also. It makes sense to leave 2 to the 12th in exponent form. It may make more sense, for instance, if you had 2 squared to leave it as 4, but let's just do the numbers the same as we'd have the variables. Okay, just to remind you that we add exponents when we're multiplying and there's 2 copies of the base, and we multiply exponents to distribute. Okay, just to remind you again, x squared means x times x, and then x cubed is x times x times x. That's why we can just add the exponents. X squared cubed means x squared times x squared times x squared, and if you add 2 plus 2 plus 2, that's the same as 2 times 3. Okay, back to distributing. Whether you can leave it as a to the negative 6 or whether you have to turn it into a fraction depends on the directions. And the directions say the answers should have positive exponents. A to the negative 6 is 1 over a to the 6. Remember to get rid of the minus sign when you flip it. Okay, distribute. Don't forget to distribute to the 2 as well as the w. So 2 to the 3 times 4 and w to the 4. Hold on while I change my page. Okay. B to the negative 21, which is 1 over b to the 21. D to the positive 6. I'm going to do this in 2 steps. Multiply exponents to distribute, add exponents to combine. These are all pretty similar to the previous things.